computer. There we go. Okay, so this is our chart, right? So here's our chart. So we're going to go back to the lab to go back to where the 30 degrees is. Okay? So here's our website up at the top. So those of you guys, if you're doing it later, make sure you have that highlighted. All right, so what I want to do is I want to turn on my laser. So remember, our materials are here, air and water. To turn on your laser, you press the red button. Okay, and I'm going to swing this around till it hits 30 degrees. I'm going to go right over the 30 degree. This is my reflected line. This is my refracted line. Notice that if it was just air through air, as if no boundary was there, this light would travel in a straight line. There would be no reflection or refraction because there's no boundary. It's only until you get a boundary surface that you get the reflection and refraction taking place. So water, notice what happens to that line, right? Here it's coming out at just about 30 degrees, right? So I don't think my protractor is just right. So let's move it just slightly. There we go. Right at our 30 degree. Okay, so, all right, so if there was no air or water, yeah, that's fine. Okay, so if I switch it to water, notice my angle got smaller. So that's what I'm measuring right here, this angle with respect to the normal, and this angle right here. Okay, so if I go back to my chart, my reflected angle is 30, my refracted angle is about 21. So I'm going to bounce back to here, and I'm going to say, okay, when my incoming angle is 30, my reflected angle is also 30, and my refracted angle is 21. Since this angle got smaller, it went towards the normal. So that means my angle got smaller and it's swinging towards the normal. So again, to show you that, it would have come out here at 30, but it went this way. It went towards the normal. Okay. Now, what I want you to add to this today is the question is, how much light actually reflects? So this is an intensity meter to tell us the percentage. So it's telling us here that 3.06% of the light bounced off of the water, which means 96.94 went through. So those should add up to be 100. So when you go back to your data table and it asks you how much reflected off, it's 3.06. How much went through? 96.94. So the question will be, does that change with different angles? Do I get more light reflecting if I change my angle there? Okay. All right, does anybody have any question on how I did that?
What was the number again for the reflected and refracted?
The refracted, I got to be 21. So if I go over here and I move this meter away, I measure that to be 21.
Ms. Rasweber?
Yes.
How do you turn on the laser?
You press the red button.
Red button?
Hit that red button. It'll turn it on and off.
Got it.
Yeah.
Thank you.
You're welcome. So what do we do next? We go to 45, right? 30, 45. Go get down to 45. Notice my reflected line also is at 45, but my refracted line is at 31. So I go back to my chart and we say 45, 31. The angle got smaller, so it went towards. But what does it look like for intensity? If I go to the intensity and I put this on there, ooh, 5.19. So more light is bouncing off at the higher angle. 5.19 to 94.81. Okay, so if I go back to my chart, 5.19, 94.81. There we go. Okay. You continue that for 60 degrees, and then you're going to do the water air. So when I want to switch, I come over here, I'll shut that off, bring this up, and I want to switch my material, this one to be water, and then this one to be air. Okay, so you guys can work at your own pace. Here are the questions that I'm going to have you answer. So again, if you want to take a picture of these with your phone, so that if you finish and everybody else is still working, or I'm working with somebody, you have these questions. These are the questions that I want you to answer at the end when you're all complete.
Can we finish this after class if we don't finish?
Yes,
Okay.
but everybody needs to stay in class and work on it in case you have questions, because there's some places that are a little tricky and you'll be like, oh, what do I do there?
All
So
right.
let's at least get through the water air boundary, the first two. That's the goal. Because there's some things that are going to come up. Okay, so I'm going to go back to this. Oops. Okay, everybody getting a couple data points, know what they're doing? Luke, a little lost? Or you good? No? Is it your internet connection? That's the challenge?
I'm not sure. No. Just some
Yeah, it's his
cookies on
internet
the
because
table.
it says its bandwidth is low.
Yeah, I think it's the internet for Luke and Drew. Probably bouncing back and forth from the site to trying to do it. So maybe it'll work better when you're both, when only one of you is on it.
Ms. Rosweaver,
Yes, Drew.
I'm confused on how you got the 21 and 31.
Okay.
How did you get that?
Okay, if you go back here,
Well,
right?
me too.
Okay, I'm going to go back up to our setup, right? It was air
Mm-hmm.
and water. Okay, so for air and water, when I shine on this, right? If I'm at 30 degrees, the 21 is the angle down here that it has when it goes through. See,
Okay.
10, 21.
Okay,
Yeah.
thank you.
You're
Thank you.
welcome. When I go to 45, the theta 2 is the angle you have in refraction.
Mhm.
Theta R is the angle of reflection.
Mhm.
So it's the angle of the darker line after it goes through the material.
Okay, thank you.
You're welcome.
How do you get the refracted angle?
See at the bottom here? That angle is your refracted angle.
Okay, I see it. Thank you.
You're welcome. What angle? The darker line, once you go into the material.
And how do you figure out if it's going towards or away?
Hold on one second. Okay, so how do you know whether it's going towards or away? So look, if I just had air and air, right, it would go straight through. Okay, so watch down at the bottom, the light that's at the bottom, which way does it bend? So if I switch this to water, it bent to go towards the normal line, which is our dotted vertical line, right? So that means towards. So if my angle decreases, I go to towards. If instead, so that's water to water, it's straight. If I bend away, my angle is going to get bigger. So watch this one. See how it went further away, right? So if I'll show that again, this is if it goes straight through. But if that angle gets bigger, because right now that angle is like 45 degrees, and now it's 67, almost 70 degrees, right? So it's swinging to become a bigger angle. Ryder, a quick question or any question?
How do you get the second refracted angle?
Okay, so look on the, see my screen?
Yes, ma'am.
The second refracted angle is the angle at the bottom, what the darker line makes after it goes through the boundary surface. So down at the bottom right here.
Do you have to flip the air and water?
For the second round, you do. So here's air with air or air with water. So if you're still on the first one, you should be here, right? So this is your refracted angle in here.
Could you do it for the 60 degrees? Because that's the one I'm on.
Air and water.
Yes, ma'am.
Yes, so here's 60 degrees, right? Air on top, water on the bottom. So this is your refracted angle. How much is that?
I got 40.
40 is correct, yes. Your reflected angle is about 60, and notice about 12% of the light is coming off of it. So that's pretty high. So the sharper your angle, the more light gets reflected off of the water. Compared to what goes in it. Okay, gentlemen, for the sake of time, we have about 5 minutes left. I don't know if any of you are on the water air, but something really strange starts to happen in the water and the air one. Did anybody get to 60 degrees on water and air?
Yes, ma'am.
What'd you notice, Antonio?
It starts to go back into the water instead of going through.
You're right. Okay, so everybody else, if you want to just pause real quick. If I go from water into air, it is now starts to bend away from the normal. So if I go down in here, so here's 30 degrees. Okay, so notice my angle got bigger. And if I swing over here to 45, same thing, my angle is bigger. If I keep on swinging, eventually, since it's bending away from the normal, you reach a point where it actually comes out of the air and goes back into the water. So when you go all the way down here to that 60 degrees, it actually undergoes what we call internal reflection. And that is what typically is not like a mirrored surface becomes a mirror. So remember yesterday when I had you get your glass of water and I said underneath there, it looks like a mirror? That's kind of the upside down version of what you're seeing here in this lab. When water's trying to go through light is trying to go through water and hits the air, it actually will bounce back in when the angle in which it hits it is pretty high. So yesterday I said, when I'm looking at a certain angle, if I kind of look right over top, I can start to see my fingers. But when I'm back here and I look into the water, I can't see my fingers because the angle at which the light has to come out and hit the water boundary, it actually ends up reflecting back in. So for that part of your data table, there is no refracted angle. The reflected angle definitely is still 60. So what we should see here is all reflected angles are the same as the incoming. But here on 60, I do not get any refracted angle, so I can't put down any angle there, which means I can't say whether it bends towards or away from the normal. So I'm going to put an NA, which means non-applicable, or you could write none, which means 100% of the light is reflected and 0 is refracted. So if you see that, again, anywhere on the problems going forward, that's how you want to answer that. So again, that's pretty unique, right? Air and water, you think you should be able to see through the water. And I would here, the intensity gets more of what's coming out being reflected, and you eventually reach a point that it actually doesn't even go in. So you see how it passes right there. It's skimming the top of the water and then only being reflected and follows the law of reflection. Ryder, your question?
I'm still a little bit lost on how to get the second refracted angle.
Okay.
So I got the first one, which is 40. Would you put the would you move the laser to 40 degrees?
No, you're just recording that in your data table, right? So if we go back to the first one, and that was for 60 degrees, right? When I came in at 60, my refracted line was 40. So all I have to do is go over here and say, at 60, my reflected angle was 60, but my refracted angle was 40, which means it bent towards. Right?
Yes, ma'am.
So you don't have to do anything again. You're just recording what happened to the light as it went through the boundary surface. Some of it bounced off, and if it did, it bounces off at an equal angle. If it passes through, it bends to make the angle smaller, which means it bends towards the normal. And the higher the angle, the more light reflects than what is passed through. And then what you're going to do next is switch the boundaries. You're going to put water on top and air on the bottom and repeat the same thing.
Mr. Rasler,
Yes.
how do you find those numbers?
What do you mean, how did I find those numbers?
The reflected and refracted intensity.
Oh, you see the green tool right there?
Yes, ma'am.
You just take that and you put it on the light.
Oh, okay.
So
Thank
that-
you.
Yep, so now originally this thing is down here in the box over here.
Right.
In your toolbox, and you have to drag it up there. Okay?
Wait,
But-
so if it passes, like the angle is past like the line in the middle, does
Uh-huh.
that mean if it goes up, does that mean it's away
Well,
from?
no, it means it totally reflected.
Oh, okay.
So that's going to happen here in this case when I go from water back into air. It never went into the air. It just only reflected. So 100% of the light is reflected. There is nothing down here, right? 100% of your light has come out and got reflected.
Okay. Thank you.
You're welcome. All right, gentlemen, I just want to make sure that everybody has these questions. We only have about 2 minutes left. So when you finish, I'm not sure why, when you finish with the data table, you're going to answer these questions. So if you have your cell phone, take a picture of those. I just don't have everybody's email. It'll take me a while. So one thing next week, I'm going to get you all to type your emails into a spreadsheet for me. So on things like this, I could just have emailed you all a copy of this. Blackbaud is just so unreliable. So I could put it in Blackbaud, but it'll take a while to explain that all to everybody, how you get all that information. So if you understand and you know what you're doing, you can go ahead and go. Those of you guys that might be having a little bit more trouble, you're welcome to stay back and I'll be happy to answer some questions for the first couple minutes. But otherwise, it's the weekend. Remember that none of this is due until Tuesday. So if you come in live to class on Tuesday, you're going to bring me a hard copy of this Tuesday and bring it in and give that to me. If you are still virtual on Tuesday, you will email it to me on Tuesday. I don't want anything over the weekend because I have too much papers emailed already to be graded. It'll just get lost. Okay?
All right. Thank you. Have a good weekend.
Thank you.
Thank
Welcome.
you.
You guys have a good weekend.
You too.
Are discussion questions homework?
Yes.
And do we have to do anything for the graph for homework?
You just have to finish collecting all the data. So you have to complete the data table for all those scenarios. You're going to keep on doing that on the website. Okay. And then you are going to answer those questions. So if you did not write down the name of that website, if you think you're going to log off and come back to it, make sure you pin it or something like that. Okay. So for homework, you're going to finish the lab to finish that, and then you're going to answer those questions. And that can be answered on another sheet of paper or on your lab paper. Mark, any questions? You think you're doing it all right?
Yeah.
Okay. You're gonna,
I take a picture of the chart.
sure. Did you get the questions?
Uh-huh.
All right, there you go. There's the chart. Justin, can I help you with anything?
Yes, ma'am. So like on the reflection angles thing, does it always stay the same?
Yes. It should.
So,
That's what the law of reflection. It doesn't matter what material you're going into. Anytime you hit a boundary surface, if reflection takes place, it'll bounce to give you equal angles. Yes.
oh, okay.
Any other questions?
No.
Okay, you have a great weekend.
Okay. Bye.
Bye.